Assalamu alaikum students. Today our topic is current electricity and subtopic is electric circuit. SLOs of this topics are define electrical circuit. Second SLO is describe the characteristics of series and parallel combination of resistors. Third SLO is drive the effective or equivalent resistance of a number of resistors connected in series and in parallel. An electric circuit is a path or line through which an electrical current flows. The path may be closed, that means joined at both ends, making it a loop. A closed circuit makes electrical current flow possible. It may also be an open circuit where the electron flow is cut short because the path is broken. From the diagram, you can easily understand the open and closed circuit. In this diagram, you see this circuit is a closed circuit. Bulb is lighting. Here, switch is on. This is the key. Key means switch. Switch is on position, right? Battery, it is connected with battery. Battery is connected with bulb, and bulb is connected again with switch. So this is a closed circuit. Circuit is not broken and it is closed. Bulb is glowing. In the next circuit, you see this is called the open circuit. In this circuit, switch is off. You see, switch is off. Bulb is not glowing. All right, so this circuit is called open circuit. Keep in your mind, if the switch is on, the circuit is called closed circuit, and if the switch is off, the circuit is called open circuit. Components of a circuit. A simple circuit consists of a source. Source means cell or battery that drives the electric charge around the circuit. What is the function of the source? The function of the source means cell or circuit is that drives the electric charge around the circuit. Second component of the circuit is load. Load means the appliance, the thing which you are using. Here load is bulb, which converts electrical energy to other forms of energy to perform a function. Load can be bulb, fan, or a TV, AC, anything. Load means anything, any machinery that converts electrical energy to other forms of energy. Second components of the circuit, third component of the circuit is conductors. Conductor means wire. Wire, for example, copper wire, which connect all the components. All right, and fourth component of the circuit is a switch. The work of the switch or function of the switch is to open or closes the circuit. You see this diagram here, all the components are connected in the form of a loop. This is a symbol of the battery, two lines, one small, one big battery or cell. Simply if there are two lines, that is cell, or if there are more than two lines, that is battery. Connecting wires, this is connecting wire. Switch or key, that is the symbol of the light bulb, that is the bulb or load, and this is wire. So this a simple circuit consists of all these four components. Series circuit. In a series circuit, the components are connected one after another in a single loop. You see in this diagram, this is a series circuit, diagram of the series circuit. A battery or cell which provides voltage to the circuit. R1 is the resistor, R2 another resistor. Both the resistors are connected in series because the components are connected one after another. This is one resistor and this is second resistor in a single loop. A series circuit has only one path through which an electric charge can flow. You see, only one path, this path. The charge can flow. I is used for current. Characteristics of a series circuit. In this series circuit, when the resistors are connected in series, so there are some characteristics which obey the series circuit. The first characteristic of the series circuit, in a series circuit, the current passing through at every point in each resistor is the same. For example, this battery provides the voltage, and the current passes through each resistor is the same. The amount of current over here is same as the amount of current over here, or at point this, at point this, at point D, at point E, and at point B. Everywhere, if you check the amount of current in this series circuit, the amount of current is same. That is, the amount of current of the battery is equals to the amount of current in I1, in I2, or in I3 everywhere. Okay, the amount of current remains same in series circuit. Second characteristics of the series circuit is the sum of the potential difference across each resistor is equals to the potential difference across the whole circuit. For example, if I use the cell of 9 volt, so the V1 plus V2 plus V3 is equals to 9 volt. If V1 is 2 volt, V3 is 5 volt, and the V2 is 5, V1 is 2, so 7, and suppose V3 is 2 volt. So the sum of all these circuit resistors is equal to the potential difference of the battery, and that is called, that is 9 volts. Okay, that means V is equals to V1 plus V2 plus V3 and so on. All right, these are the two characteristics of the circuits and connected in series. That is, I is equal to I1 is equal to I2, and V is equals to V1 plus V2. Characteristics of a parallel circuit. You see the diagram of the parallel circuit. All the circuits are connected in parallel. All right, you see all the circuits are connected in the parallel. The left side of the circuit are connected with one end of the one terminal of the battery, and the right side of the circuit is connected to the other terminal of the battery, not end to end. All the left side is connected with one plus terminal, and all the right side is connected with the negative terminal. In a parallel circuit, the components are connected to the EMF source in two or more loops. Here there are four loops. 1, 2, 3, 4 loops. Okay. A parallel circuit has more than one path through which electric charge can flow. There are more than one path. You see, the current is divided over here. I1 into I2 into I3 and into I4. So current is divided into four parts. Effective or equivalent resistance of a number of resistors. Effective or equivalent resistance of a number resistance means when the resistors are connected in series, so total resistance is equals to the R1 plus R2 plus R3. Effective or equivalent means total resistance of a number of resistors. Here we are using four resistors connected in series. So drive the formula to find out the effective or total resistance of the circuit. The current I that flows through R1 and R2 is the same because they are connected in series. I1 is equals to I2 and is equals to I. Since we know that V is equals to IR according to the Ohm's law. So V1 is equals to IR1 or V2 is equals to IR2. In series circuit, the sum of the voltage across the resistance of each individual resistor is equals to the voltage supplied by the source. That means V is equals to V1 plus V2. So put the values of V1 and V2 from the above over from this portion over here in equation number 1. Instead of V, we put IR. Instead of V1, we put IR1. And instead of V2, we put IR2. Take I common over here, I common, and then R1 plus R2. Cut I on both sides. What is left? R is equals to R1 plus R2. So this is the effective or equivalent resistance of a number of resistors are connected in series. If you have 3 resistors, add 1 V3 or I3. If you have 4 resistors connected in series, you have to add I4 also. According to your diagram, according to your need. I am using only 2 resistors. Here the diagram is showing 4 resistors, but I am driving the equation with 2 resistors. This equation or formula is derived. This formula shows that the effective resistance when the resistors are connected in series is equals to R1 plus R2. That means total resistance is greater than the individual resistance when we connected the resistors in series. Effective or equivalent resistance of a number of resistors connected in parallel. In a parallel circuit, the potential difference across separate parallel branches is the same. That is, potential difference is equals to V1 is equals to Vt. That means potential difference or the voltage of the battery is equals to potential difference of each resistor. If I am using 9 volt cell, then V1 also get 9 volt or V2 also gets 9 volt. But we know that according to Ohm's law, V is equals to IR or I is equals to V upon R, or I1 is equals to V upon R1 and I2 is equals to V upon R2. The current I is split into I1 and I2 because R1 and R2 are connected in parallel. In series, V is V1 plus V2 or I is equals to same. But in parallel, potential difference is same and current is split. Current is the sum of the batteries like this. I is equals to I1 plus I2. This is equation number 1. Now put the values of I1 and I2 from this equation. That instead of I, we have to put V upon R. Instead of I1, we have to put V upon R1. Instead of I2, we have to put V upon R2. Like this. Okay, in this we have to put the values in equation number 1 like this. Now take out V as common over there. Take out V as common. What is left? 1 upon R1 plus 1 upon R2 plus 1 upon R3. Now cancel this V to this V. What will be left? 1 upon R equivalent is left and 1 upon R1 plus 1 upon R2 plus 1 upon R3 is left. This is the derived equation of when the resistors are connected in parallel. I hope students you will understand clearly when the resistors are connected in series and parallel and the characteristics of the series and parallel circuits. Thank you boys and girls.